A free fall is a vertical motion with constant acceleration where the initial velocity VO is equal to 0 and the position traveled S is equal to the height traveled by the particle. To further understand, let's make an illustration. So we have a particle from higher elevation, and here's your ground. So the particle moves on a vertical motion. So the particle moves from a higher elevation with initial velocity of 0 until it hits the ground with the final velocity V, where the position or the distance traveled is equal to the vertical height. And the constant acceleration here is the gravity, which is equal to 9.81 meters per second squared. So, applying the three kinematic equations of motion with constant acceleration. So we have first the equation for the velocity as the function of time, where A is equal to G. So your velocity is, initial velocity is 0, therefore we have V equals GT. Next, the equation for S as a function of t, we have S equals VOT plus GT squared over 2. So, knowing that V is equal to 0, we have S is equal to, so your S here is equal to H equals G T squared over 2. And the next equation for the velocity as a function of position, wherein the original equation is V squared equals VO squared plus 2GH. So this is 0. We have V squared equals 2GH, where V is the final velocity when it hits when it hits the ground. G is the gravity and H is the height or the vertical distance traveled. So to further understand the problem, let's take a sample problem. So we have this. A ball is thrown vertically upward with a speed of 15 meters per second. Determine the time of flight when it returns to its original position. So let's try to draw the figure. So the figure would look like this. So we neglect a resistance. So we have a ball here, and it is thrown upward till it reaches here. So with an initial velocity of 15 meters per second. So when the ball is thrown upward, it will reach a certain height h, and then again, after reaching the height h, the ball will go down and it will be back to the ground. So we are to solve for the time of flight from the start of its motion until it returns to its original position or to the ground. Therefore, the distance traveled is 2h. We have upward and downward. So that is the total distance traveled. Now, let's solve. So first, let's solve for the time for the upward motion. So here, your velocity on its highest position is equal to 0. So we can use the formula for the velocity as a function of time. V equals VO plus GT. So here, your final velocity is 0. Initial velocity of 15 meters per second plus G of negative 9.81 times T. So by transposition, we have 9.81 T equals 15. T is equal to 15 divided by 9.81. We have 1.529 seconds. So this T is the time it takes to reach the highest position H. Now, let's solve for the value of T during the downward motion, or the time it takes from the highest position back to its original position. So we have the equation for free fall. So here your VO is equal to 0 and your V here is 15 meters per second. So we have V equals GT. So 15 is equal to 9.81 T. So we use here positive sign because the force or the direction is towards the gravitational pull. We have T equals 1.529 seconds. So same as this. So the total time traveled equals 1.529 plus 1.529, so that is equal to 3.06 seconds. So that is the total time traveled by the ball until it returns to its original position.